Hi, my name is Ariella Hoffman-Peterson, and today I'm going to be talking about a trust maturity model I developed with my team about how we can make AI more trustworthy within the healthcare system. So, maturity model, looking at the one on the right-hand side as an example, is a multi-stage framework that depicts an organization or a team's progress towards maturity in a specified area. So, it is a maturity measurement tool. And if you look at the example here on the right, this is about cloud data governance maturity. And if you read through sort of what levels 1 through 5 look like for each dimension, a lot of it has to do with creating more formal structure around governance and around responsibility of different actors to formalize processes and therefore make them more mature and intentional. So what we wanted to do is create a maturity model using trust as our focus. And so what trust is a willingness to accept risk or be vulnerable to another for a given set of tasks. So why might we trust a doctor or a healthcare system? Because of the example attributes of trust that they might portray, such as empathy, honesty, integrity, reliability. But trust can be changed over time. It is relational, it's dynamic, and can mature over time. And that's what we want to capture within our maturity model. So we chose specific audience and use case for our maturity model, assessing AI model or tool trustworthiness. And so committees or structures, existing structures, or AI governance committees within a health system can use this tool to assess whether it's ready and trustworthy enough to be implemented within their system. So what we did to create this maturity model, we evaluated 10 established AI trust frameworks and compare them to each other to find kind of what the most representative one was. And we, through this mapping process depicted here, came up with the Coalition for Health AI's set of trust attributes to be representative of many of the other frameworks, and therefore we use those to create our maturity model. So here in the table are the tri-attributes we used as our dimensions of maturity. And so this is the kind of template we use to think about how to create our maturity model, where we put the tri-dimensions along the left-hand side and then start to ask questions that help a health system or a health system committee assess whether the particular tool is mature in various dimension areas. And so we created survey questions, broke them into 3 areas: technology, process, and people, to be able to create a picture of overall maturity of a tool. How do you use a maturity model? Again, we created a set of survey questions to ask a team to think about whether this particular tool is meeting areas of maturity on our that we've just established as trustworthiness features. And when you look at this in aggregate, you can see a holistic view of maturity. And each model can be tailored in different ways to meet the needs of the specific team or institution. So for example, what this could look like, what we did was create survey questions for each of the areas of maturity. So accountability and transparency are important trustworthiness aspects of AI. So we asked questions about the technology itself, such as how has the algorithm been built to be auditable? We talked about process, such as are reports from audits designed for user interpretability? And then we talked about what people were involved in that process, making sure that compliance professionals and others were consulted when thinking about an audit trail that could build trustworthiness in that tool. So that was just one example, but we went through each dimension and asked those questions. And this is a useful tool because it helps bring robust research frameworks to on-the-ground practice. You can look at a maturity score in a quantitative way, but you can also guide a discussion around a committee making a decision about an AI tool. And maturity models, they're flexible, they're scalable, they're tailorable. But we also know that they need to be specific enough that we could use many different maturity models around trust and AI. So for example, future work could include maturity model focusing more on social determinants of health within this context. And we also have been doing additional work on reviewing this with different expert groups to validate the instrument. So thank you so much for your time today. This slide is just our team members and our contact information if you would like to continue the conversation. And thank you again.
Greetings. My co-authors and I are excited to share with you an opportunity for us to collaborate on advancing CBK-enabled learning health systems. This talk is a direct follow-on to a lightning talk presented at last year's MCBK Global Meeting and extensive developments that talk drove. We started last year's MCBK Lightning Talk with this slide that reinforces how far healthcare is from realizing the quintuple aim. That is, where we optimize health, reduce costs, satisfy patients and care teams, and achieve health equity. We noted that learning health systems that produce the virtuous cycle depicted in the center of the slide are essential for closing this gap, and that interoperable CBK is critically needed to make information flow around this cycle efficient and effective. That MCBK Global Lightning Talk last year outlined an AHRQ-funded initiative that gathered hundreds of stakeholders to produce a future vision, action plan, and concept demonstrations for a knowledge ecosystem that supports CBK-enabled LHS cycles. It also outlines stakeholder-driven efforts to continue this work after the ARC funding ended, focusing on specific targets such as pain and opioid management. The talk proposed forming a work group to explore creating a network of networks to cross-fertilize and speed current efforts that are somewhat siloed but ultimately interdependent. The call to action generated rich discussions during both lightning talk sessions, which prompted a flurry of explorations immediately after the meeting. These led to a summit attended by over 70 people the following month to launch an initiative to address the opportunities outlined in the lightning talk. The initiative launched at the AMIA 2023 annual meeting was named Accelerating Care Transformation, or ACT. A key feature that differentiates ACT from the predecessor stakeholder-driven efforts to execute the ACTS roadmap is a steering committee of representatives from diverse stakeholder groups. Initial ACT efforts involve helping these steering committee members and others accelerate progress toward the quintuple aim on their strategic initiatives. The approach for this support is to build on prior foundational work, such as output from ACTS, cross-fertilize interdependent but currently siloed efforts, and leverage enablers that ACT can bring to bear. The targets of interest to steering committee members that ACT is currently focused on include pain and opioid management, hypertension, chronic disease, and several others, chronic kidney disease, and several others. This slide lists current ACT steering committee members. We anticipate the membership will grow over time to include additional stakeholders and groups. This slide outlines care transformation and LHS enablers that ACT is bringing to bear. They're driven by resources and capabilities from the steering committee and related foundations that ACT is building on. All these enablers can help ensure that CBK plays its essential role in driving urgently needed progress towards shared goals. One enabler I'd like to call out is collaboration with HL7's LHS work group on a series of HL7 connectathons beginning this January. These connectathons will demonstrate in advance how standards-based information flow related to the ACT clinical targets can support care transformation and LHS efforts for these targets and beyond. Just as last year's MCBK Global Meeting quickly resulted in forming ACT, we're hopeful that this lightning talk will likewise help ACT enhance mutually beneficial collaborations on a global scale. All of you listening to this talk are presumably holding at least one puzzle piece needed to achieve the shared future vision. This makes you a potential stakeholder in ACT activities. This slide outlines examples of mutually beneficial ways you could engage with ACT activities. For example, connecting your work with ACT efforts on specific targets and participating in the connectathons and other care transformation and LHS enablers ACT is providing. We're excited to hear your thoughts during the discussion and hopefully begin cultivating new win-win-wins with you after this conference. Thanks.
Hello, everyone. My name is Elisavet Andrikopoulou, and I'm so excited to talk to you today about bridging the gaps between health informatics and computer science education. As many of you are aware, there has been significant process in creating and mobilizing computable knowledge, or CBK, over the years. But as with many advances, new challenges have emerged. The MCBK UK group, which focuses on mobilizing computable biomedical knowledge in UK, has been working to engage a more diverse audience, which includes academics from people from academia, computer science, and of course, health informatics. At the 2023 UK conference, one of the key concerns was raised on the difficulty to introduce early career professionals to MCBK concepts. The idea we had was very clear. We need to make these concepts more accessible, easily to those who are completely new to the field to understand. As part of this, we decided to involve students using their fresh minds, eyes, and ideas on the subject. This would help them understand this MCBK and provide valuable feedback for future engagement strategies for us. We tasked master-level students from the University of Portsmouth School of Computing to develop workflows that represent the mobilization of CBK, following the principles outlined in the manifesto. The students came from a number of MSc projects, mostly in data analytics and computer science, and formed groups up to 6 members. Their task was to present their findings in a conference-style meeting. And the key element of the assignment was to develop a BPMN diagram, business process modeling notation diagram. And these diagrams, they meant to represent how the CBK can be mobilized to address the FAIR principles, making knowledge findable, accessible, interoperable, and reusable. In total, we had 11 groups with 51 students participating. The most important thing was only 2 of the students had any prior knowledge of health informatics, which really amplified the challenge. At the beginning, many students considered the task mundane, just any other BPMN diagram exercise. But very soon they realized how difficult it was to interpret MCBK and apply it effectively in their diagrams. Most groups use the BPMN notation sufficiently, but here is where it gets interesting. Despite our best efforts to explain what MCBK is not a product or service, but rather a community of experts working on CBK mobilization, only one group actually grasped this concept. The majority of the students defaulted to a clinical setting, with CBK represented as a database or a data warehouse storing health records. Only that one group, which had no prior knowledge of health informatics, took a different approach. They portrayed MCBK as evaluators of interoperability, a concept many others missed. This gap in understanding raises an important point. Language and clarity matter. We as experts sometimes overlook how terms like MCBK can be misinterpreted by those outside the field. So I believe there is a clear need for some more precise language, maybe some even simpler language when communicating these concepts. So what do we learn from all this? Well, the students found the task far harder than they expected. And one limitation to note here is that the BPMN section of the task didn't carry as many marks as the other sections of the assignment. This meant that students, understandably, didn't spend as much time on it as they might have otherwise. After all, their MSc projects are in computer science, not health informatics. While the students struggled with some of the health informatic aspects, they also demonstrated a willingness to engage deeply with the material, and that's something we can build on for the future. Thank you very much for your time.
First, I'd like to thank the organizers for inviting me to give a presentation on principles and standards for managing integration and interoperability in intelligent and ethical transformed healthcare systems. First, I have to introduce the transformation of health and social care. Currently, we are advancing from phenomenological medicine for evidence-based medicine, person-centered medicine, and personalized medicine towards personalized, preventive, predictive, participative precision medicine, abbreviated as 5PM. It considers the individual health status conditions, genetic and genomic dispositions in a comprehensive, that means personal, social, occupational, environmental, and behavioral context. That way, we are turning health and social care from reactive to proactive. However, this requires the advancement of communication and cooperation among the business actors coming from different domains, disciplines, using different methodologies, terminologies, ontologies, and having different education skills and experiences from data level to knowledge level. That means from data sharing to knowledge sharing. The challenge thereby is the understanding and formal as well as consistent representation of the real-world ecosystem. That means multidisciplinary dynamic systems in variable context to enable mapping between the different disciplines, their methodologies, perspectives, intentions, languages, etc. If you do not understand the components, functions, relations of the real-world ecosystem, that means its knowledge and concept space, we can never formulate the requirements for properly modeling and formalizing the ecosystem. Therefore, we cannot decide on correct integration and interoperability at data level, but shall do this at real-world business system level for each use case. The objectives of 5P medicine are provision of optimal health services everywhere and anytime, thereby individualizing the system according to the status, context, needs, expectations, wishes, and environments of the subject of care, making him the process manager. And finally, the integration of different actors from different disciplines, empowering the subject of care, thereby using their own languages, methodologies, terminologies, ontologies, thereby also meeting any behavioral aspects, rules, and regulations. That means enabling a mutual comprehensive understanding. Furthermore, we have to guarantee usability and acceptability of 5P medicine solutions. For doing this, we developed the ISO standard 23903 interoperability and integration reference architecture, providing a model and framework. This is a system-oriented, architecture-centric, ontology-based, policy-driven approach, thereby also including the software development process according to ISO 42010 and ISO 10746. Thereby, it extends those standards by the real-world business viewpoint and details also OMG's model-driven architecture, computation-independent modeling by providing more details and methodologies. That way, it combines architecture, knowledge representation and management, systems representation, modeling and implementation standards for systems design, development, integration, and interoperability. Thereby, it defines basic principles and paradigms and provides generic specifications to practically design and manage interoperability and integration challenges in dynamic, complex, context-aware, multidisciplinary health ecosystems as systems of systems. This is the approach, the generic reference architecture representing the different domains perspectives, the composition and decomposition of the system's elements, and the development process through the IT viewpoints extended by the real-world business viewpoint. The latter is represented by the domains ontologies, while the others are represented by ICT ontologies, for instance, the enterprise knowledge using the business process systems representation, the informational representation using terminologies, glossaries, etc., and data representations using data models and database schemas. For mapping them, we are using the top-level ontology 21838. So we can integrate and provide interoperability at each viewpoint between any domain at any level of complexity. First, when integrating different components, we have to define the domain they represent, the viewpoint and the granularity level, and then we can place the right components we are looking for, file resources, terminologies, code system components, whatever, into this model, representing this architecturally according to this approach, and then transforming the real world system representation into this viewpoint representation, and then adopting the components, correcting them, extending them, etc., to provide correct solutions. Transforming healthcare towards knowledge-based, personalized, preventive, predictive, participative precision medicine addresses health and social care supported by technologies such as advanced computing, artificial intelligence, autonomous systems, beside miniaturization and mobility. Beside the opportunities, those advanced technologies also be a risk to be managed, and therefore the behavior of intelligent autonomous systems from a humanistic, moral, and ethical perspective is an important aspect of designing and managing advanced ecosystems. The flexible, scalable, business-controlled, adaptive, knowledge-based, intelligent ecosystem must follow a systems-oriented, architecture-centric, ontology-based, policy-driven approach, standardized as ISO 23903 as presented. This enables the formalization of any systems representation from planes through cars up to planets, and the integration including ontology mapping supported by appropriate tools. So enabling comprehensive communication and collaboration between all components, including actors of ecosystems. This approach is meanwhile used in a series of ISO, IEC, CEN, OMG, IEEE, and HS7 standards, and is mandatory for all multi-domain projects. Thank you so much for your attention.